Okay, we have another problem here. Let's rewrite each of these in standard form. On the first equation, let's add y squared to both sides. This will give us 4x squared plus y squared equals 4. And for the second equation, I'm going to subtract the 9x squared off of each side, so I can have minus 9x squared plus 16y squared is equal to 144. Okay, I'm going to choose to cancel out the y squareds, multiplying that first equation through by negative 16. That will give me, let me move this up a little bit here, this gives me negative 64x squared minus 16y squared equals negative 64. And the bottom equation just slides over and nothing changes. Adding down, we designed this so that the y squareds would cancel each other out. We have negative 73x squared equals 80. And that gives us x squared equals negative 80/73. Well, x squared cannot equal a negative number, and therefore we know that there will be no solution in this case. Find the dimensions of a rectangle whose perimeter is 56 centimeters and whose area is 192 centimeters squared. We know the perimeter formula for a rectangle has 2 lengths plus 2 widths adding up to the perimeter, which is 56. And we know that the area formula is length times width. That will equal 192. So there are two equations that we can work with. I'm going to choose to simplify this first equation by dividing by 2, and that will give us L plus W is equal to 28. And if I isolate the L in that second equation, I can rewrite that as L is equal to 192 over W. And I'm going to substitute that second equation into the first equation because standard elimination is not going to work. This will give us 192 over W plus W is equal to 28. Which we don't want to solve as is. We do notice that W can't be 0, but that wouldn't make sense in a rectangle problem anyways. So let's multiply through by W. We will have 192 plus W squared equals 28W, which we can now put into standard form. We will have W squared minus the 28W over to the left plus 192 is equal to 0. And I don't want to jump into the quadratic formula to solve this. I do want to try and factor it. It is a word problem, and usually these are factorable. Now, how would you go about doing this? I know I'm kind of going backwards in our skills here, but I would go with factor trees. I'd start, or factor pairs, 1 times 192. 2 times something, that's 96. 3 goes in also, 3 times 64. I'm still trying to find numbers that are 28 apart, and these are still a bit apart. So let's try 4. 4 times 48. 6 times 32. Okay, close, but that's not going to make 28, is it? So let's keep on going. 8 times 24. Notice as one list is increasing, the other list is decreasing. Turns out that 12 times 16 is our winner here. We're going to have W minus 12 and W minus 16. Hopefully your numbers aren't that bad when you do a problem like this. And we find that W equals 12 centimeters or W equals 16 centimeters. Okay, let's go all the way back up to the top here. We need L, and we know that L plus W adds up to 28. So L here would be 16 centimeters, or L here would be 12 centimeters. It's kind of weird having a length that's smaller than the width, so I'm going to go with 12 for the width and 16 for the length, and that would be the solution to our problem. Another problem that's very much the same as the one we just did. The perimeter is 72, so 2w plus 2l is 72. And the area is 320. That means length times width is 320. Let's clean up the first equation, dividing by 2 to get w plus l is equal to 36. And I will solve for L and have L is equal to 320 over W. Substituting this second equation into the first equation gives the following. W plus 320 over W is equal to 36. We don't like that rational equation, so we're going to multiply through by W on each side to get W squared plus 320 equals 36W. Subtract that to the left, W squared minus 36W plus 320 equals 0. And I'm going to factor this a little bit more quickly this time. We'll have W minus 20 times W minus 16 equals 0. So W equals 20, this is feet, or W equals 16 feet. The length and the width add up to 36, so that would mean the length is 16 feet, or the length is 20 feet. And again, we don't like the length being shorter than the width, so here are the dimensions, 16 by 20 feet.